Hi everyone. So today we are going to talk about the new speech analyzer API, and I have been using it in Zenther AI for the chat with AI and the plan workout, and when you have to do the voice logging feature. So if you see, I have this button, and when I click on it, it will start the audio transcription. So it takes my speech and then converts into text, and then it will directly add it into the text field, and I'm using it for the feature on voice log as well. I will not show it right now because it will mess up with the audio of work this like the video capture itself. So but the idea remains the same. It's very similar to the NSSpeechRecognizer that we have been using, but now it is much better and it is available for iOS 26 only. So what I learned going through the WWDC session and their documentation is that they have a really nice sample project that you can download from the main documentation that they have, bringing advanced speech to text capabilities, and kind of just give the whole code base to an LLM, and then based on that build on this is what I have been doing in both of my apps, and it's much easier than trying to understand each line. I have understood each of line, but I'm not going to write each line by myself every single time because there's so much going on, and I feel like Apple should take and some responsibility here and make it much easier working with audio, because as a developer I do not want to deal with all the audio related stuff. I'm not an audio engineer, so that's a bit of a rant there. So to give you an idea what the speech analyzer how it works, so that you can directly use the sample project in your app but still have the concept on how it works, is that we have the main class, which is the speech analyzer class, which analyzes the spoken audio. And then in this class it will have different modules. One of the modules is the speech transcriber one, and one is the dictation one. The dictation, the on the bottom right icon that you see, it's the dictation one. So you give it the input as audio buffers, and then it you it it takes the audio buffers to the transcriber, and the transcriber will then spit out the text. And so this is a very simple idea on how it will work. So as they have the documentation that you create the necessary modules, and necessary modules is just creating an instance of the transcriber with some configuration, and you ensure that the relevant assets, so when they say assets, it's like the on-device model is available, and then you create an input sequence. The idea is that you chunk the audio into very small parts and then give it one by one, which is in the sequence, and then you create the configure the analyzer on different maybe like on how it would work, especially when you're getting the input output, like the output, what's the quality of it, and then you supply it with the audio buffers, that's the chunk, and then you start the analysis and then act on the results. So it's a closure that will give you back the data, or I think if I go back to the code, it's an async sequence as well, and then when you are done, you finish the analysis when you're done. So the documentation is nicer. I haven't opened this page before, but they have steps mentioned, and it's funny that they went from step 6 to step 8 directly, and they have step 7 above it. Okay, so we will just go through the code to understand it first. So we have the, where did that page go? Okay, we check for the supported languages that they have, and if it is not available, then you can know that it's a not supported language. I used English, so English US, so that's definitely available. Then you on the instance of the speech recognizer, you provide it the language that you found, and then said that it will be an offline transcription, and then you have to make sure that you download the asset for this particular locale, as in you install the language support that will do the speech to text recognition, and then you install it, and then you kind of wait for it, and then you create an async sequence. This is a very kind of a difficult line to understand. It's like you get the input and you build the inputs of sequence of the audio, and then you take the best available format for this given transcriber. For this you use the speech analyzer class, and then you provide the speech analyzer class with the module for the transcriber. Then you supply it with the audio. This is something that we mentioned before. You have to use a buffer conversion. So the sample projects has a very nice buffer file that you can directly use. They do the grunt work for you, which should be a part of the framework itself, but there are many different customizable options. That's why they want it outside of the framework. This is what I'm assuming. So you take the buffers, you put it into the input, and then you yield the input back. Then you perform the analysis using the instance of the analyzer, and then when you get back the analysis, you get it back from the transcriber, not the analysis instance but the transcriber instance, and then you get the best transcription, which is an attributed string. And it is an attributed string because it also mentions the time, the start and the end time. So if you want to provide a very native way of having when the words are being spoken out, you can highlight the view. This is what the sampler project does as well. And the last step is to make sure that you finish the analyzer and do not have any instance leaking. So this is the idea. So if I go back to my project and show you how I have been using it, so I don't think it's a nice view, but I have the input recognizer cancel, so I can cancel it on the go. So it starts with it starts with setting up it actually starts up with setting up the audio, especially on the iPhone. So you make sure you have the AVAudio instance, and I prefer the play and record mode, and it defaults to speaker directly because I should have the option to have the allow HTTP for the Bluetooth as well, Bluetooth EDP or something, which is an option that I can set here, which should be something, let's see, long format audio. It can be a long format one, but I forgot what's the name for the option. I think it goes here. Yeah, allow AirPlay or allow Bluetooth AD2P. Yeah, this is what I would want for working with AirPods, if I'm not wrong. And it would be spoken audio, and then I set the audio session. So this is the first part. Then the second part is setting up the audio engine itself, which we do something later on. So then you have the transcriber. So one thing that I have done in my app is that I also get the volatile results as well as the fast results. Earlier they call it frequent finalization, but now it's called as fast results. So if I try to jump to the definition and make the font bigger, it says that it will bias toward making the transcriber make it more responsive. So when I'm saying the word, the time to the first token that inputs is very less, but it's also less accurate. So this is something that you need to make sure that you understand the trade-offs of getting much more faster results, but the trade-off is that it is actually less accurate. And I get the volatile results as well because I directly want to show them, because it's just way much faster. I should not do that, especially when I'm working on this chart app. Then you have the speech analyzer where you provide the transcriber, and then you check that it is supported. Otherwise I'll just give the locale not supported. Otherwise I will install it. So these are the methods that you will find in the sample app. It will have a recorder function and another file. All I did was take it into one file itself. And then you have the input, as it said, like input sequence and input builder. So if you see, this is of the type of async stream that uses the analyzer input and then the builder as well. Analyzer input is a struct that it's a time coded. This is what I meant, because it will have some time coded data that will have the start time, and I think it does have the end time as well. And I haven't been using this feature to have the start and end time because it did not make sense for my use case of just inputting audio. But if you are using that, you should understand how it works very well. And this is the buffer converter that I meant, that I literally copy pasted. That's why I do not even have the function, because it is literally copy pasted, where you convert the buffer, get the output. There's a lot of stuff that I don't understand, but I'm okay not understanding, because I'm hoping that the Apple team did their job well on this file. And then we have the recognizer task where I have, so before that you have to set up the audio engine as well, where you provide it with the input node and the buffer size, which will be the chunk that you would want to buffer, and then process the audio buffers. When I give it back to the buffer converter that I mentioned a few lines before, which will yield back into the input builder. It's very confusing, to be honest, but once you understand the steps, I'm not going to write this code on my own ever, but I just want to understand the steps on how it works. Then you have the audio engine, we prepare it and then we start it, and then the recognizer task will do, it's an async sequence, so we get the result, and this result, if I go and see, it's an array of result, or an async sequence of result that gives me the result. And this result, if I try to open this, it has a range of the audio input. Oh, it does not, it has the start and the end time, but as a range itself. So you get that. You have the text as an attributed string, and you have the alternative strings as well, that the ones that it was trying to have, but it took the text as the most likely interpretation of the audio. And this is what you get. So in the main view, then I would just say on text received and then directly use it. So if I have to show you how I'm using it in the app, and then I would just pass it back in, oops, where is this, where am I actually using this? No, this is what happens when you're live coding, live vibe coding. Yeah, I have the voice in the voice food logger, and if I see the instance, it starts transcribing, and then I get the data. Just want to make sure where I'm getting the data from. So okay, I got it. It's not my fault. Okay, so I'm not using the on text receive closure, the name of the closure. I'm using the closure directly, and then getting the transcribed text and the volatile text. For a second I was doubting myself like anything. So this is the whole live transcriber and how it works. I hope you got a gist of it, and you will watch the WWDC session to understand how it works better. And now you have a much better idea. And as mentioned before, use the sample project to its max. That's the reason that they have provided it, and you will understand, especially after going through this video, on how you can take advantage of that using the different files that they have and directly use it into your app as well. So again, I hope you learned something new, and I'm looking I have this, the other app that I have, Arisin, is directly about it's a voice first journal, so you directly speak out. So I really needed a good implementation of the speech analyzer, so I have worked very hard on making sure that I do get that very well. So with that, I hope you have a great day, and thank you.